Okay, but anyway, I will start the introduction. So the topic is concerning the thrombotic accident in Botrops SP snake bites. And I will try to provide some information that kind of accident, which is not so common in general species of Botrops, but in our land, Martinique and Saint Lucia, we have some problem with thrombotic complication. I will try to give you some explanation. I mean, at least some clue about explanation why this kind of Botrops are complicated with thrombotic accident. This slide is also a way to thank the team which is working with me on this topic, and part of the team is here, and I'm very pleased to have you on board, all of us. Okay, if I have the next slide, please. So what's the aim of this presentation this morning? The first aim is to provide a brief summary of the thrombotic events in Botrops species envenoming. I will next go on with some updates on the specific and very, very, very specific pathways that are involved in thrombo-inflammatory process. And lastly, I will try to demonstrate that the biologic response to Botrop, specifically Botrop lanceolatus and also Caribaeus venom, can fit with this new pathophysiology, so-called thrombo-inflammatory machinery. And the first message I would like to give to you is that thrombo-inflammation or immunothrombosis is not the simplest addition of coagulation problem plus inflammation. This is much more complicated than that. It's not just a simplistic sum. Next slide, please. So what is my, when I look at the literature, there is a different kind of message that I took. The first is that there is not so many thrombotic accidents when we are regarding the scope of the complication of Botrops by themselves. There are indeed some few cases of a thrombotic accident, few case reports, mainly coming from Ecuador, Brazil, of course, and also Colombia. And Colombia is one of the most country that gives information about that kind of accident. And this part of on the left side of the slide is really contrasting to what we are dealing with in Martinique and Saint Lucia, because the thrombotic accident in Botrops lanceolatus and also Caribaeus are much more frequent. Maybe a third, 30% of patients who will not receive, of course, the antivenom were having this kind of complication by the year, let's say, 19. Thank you, Rishika. And also, in contrast with what happened in the main Botrops, the brain, the heart, the pulmonary, and also the whole microcirculation could be involved in those thrombotic events, which is not the case in Botrops from Brazil or Colombian. And I mentioned brain and mesentery, and there is only one case regarding this accident in the mesentery with mesenteric ischemia that has been published very recently. So it's just to say that it's two different worlds. The world of Botrop in Brazil, in Ecuador, in Colombia, and the world in our lands. Next slide. So when I look, I told you I'm not a snake bite guy. I'm just looking what's coming on from the literature. And when I look at, I saw, okay, Botrop SP is mainly complicated by uncoagulated blood, sorry about that, with reduction in, a lot of coagulation tests, TP, ATP, low fibrinogen concentration, abnormal platelet counts. So this kind of, feature is related to the consumption of coagulation factor, which are related to the major procoagulant effect of these kind of venoms. And also, you do have some clue about some local, of course, but also systemic inflammatory response. On the other side of this slide, you can see that Botrops lanceolatus and as well as Caribaeus, there is not so many blood test abnormalities. So this is, for me, this is just something very, very, very special that we have to understand better. Normal, usually normal, even elevated fibrinogen concentration. Again, some reduction in the platelet counts. And also, what is an important thing is here, there is very weak or even no coagulation factor consumption, which is weird, because I will show you that there is no much difference between the composition of the venom of those kind of botrops. Those diapositive suivante. Thank you. Yes, as I told you, when I look at the literature, my first understanding was quite simplistic. I might say, okay, but there should be some difference in the venom composition. And my surprise was that there was no any obvious specificity between, for instance, the composition of an atrox, a Botrop atrox, or a Botrop lanceolatus. There are some difference. I don't say it's exactly the same. There are some difference. For instance, there are a huge amount of metalloproteinase, some serine protease, as in the Botrop atrox. But these serine proteases are a little bit specific because they are more, the role in the coagulation activation is not so clear from my point of view at least. But on the other side, this kind of serine protein do have some other activity, and one of the activity I'm interested in is kallikrein-like activity, which is an important pathway for inflammation. I will go further on this idea a little bit further. So from my point of view, I can't say that there is obvious difference between a Botrop HP like Jararaca or other compare with Botrops lanceolatus. There is no such difference that may explain why on the one side you have uncoagulated blood, bleeding, and the other side you have thrombosis. I can't make this hypothesis with you this morning. Next slide. So another way to understand what is going on here is to consider that for the Botrop lanceolatus and Caribaeus, we could say it's a proposal, it's not for sure, that the thrombotic events, particularly in those two botrops, could be related to the lack of overconsumption coagulopathy due to the weak procoagulant effect of this venom. And I told you there is no reduction in coagulation blood test. And this lack of major coagulation coagulopathy is associated with some thrombogenic mechanism, including inflammatory response due to, platelet activation, immunocompetent cell, and endothelial dysfunction. And this could be the link, the way we could understand the mechanism of thrombotic accident as being a part of thromboinflammation. Yeah. So what is thromboinflammation or immunothrombosis? Well, you know the player, you know the driver. There are no specificities, there is no surprise. There is, of course, platelet activation. You have inflammation with leukocyte, with monocyte, blah, blah, blah. You have the endothelial cells, which are overactivated, clot formation, tissue factor expression. Well, you know all that. But the story is not exactly what you see on this slide. You can see on the year 2004, the group of Montreal, Tanguay, first described something that was not so well known, which is the coagulation into intracoronary stent. And they first imagine or describe some biologic features of thromboinflammation. That was the first time they used the word. And thromboinflammation in their mind was the platelet leukocyte activation through a very specific pathway, which is the binding of P-selectin of platelets on leukocyte and monocyte, PSGL1. And then, maybe 10 years after, really the main paper on this topic is a paper by Egelman, who coined the term immunothrombosis to describe the innate immune response induced by intravascular thrombus formation. And the way this thromboinflammation was starting was to destroy the pathogen, the bacteria. You know, then our group in 1980s effectively introduced the term of thromboinflammatory in bacterial sepsis, and that was also a very new understanding of the response, the immuno response of human to bacterial sepsis. And then Newand in 19 introduced a concept on cerebral stroke as being thromboinflammation, and this is a very important message here. And also, you may know what the COVID bring up a lot of information about infection by this virus and the way the coagulation and the inflammatory process are involved in the response of the host to that kind of virus. And if you read the literature, you will have a lot of idea coming from this thromboinflammation in COVID patient. We have seen a lot of progress thanks to this pandemic. Anyway, I'm back to the first message on immunothrombosis and thromboinflammation. In your mind, you should not just understand it as a simplest addition of coagulation, perturbance, and inflammation. It's a little bit more complicated. Yeah. So maybe you could, because in the literature, again, it's not so easy to have a clear point of view of what the writer, the scientists are in their mind when they are speaking about immunothrombosis and thromboinflammation. Mainly what you could understand is that immunothrombosis, the major outcome for that is vessel occlusion thrombosis in response to an initial inflammatory stimuli that could be bacterial infection, for instance, in your mind. And you can oppose this immune thrombosis to thromboinflammation, and that the main outcome of thromboinflammation is rather the recruitment of immunocell in response to an initial inflammatory system in the setting of a procoagulant activity. Though it's a little bit tricky, but again, when you read the paper, the people are not so, let's say, consistent with the division, but I think it is important to keep in mind that there is two different worlds, immunothrombosis, and this is to fight against a microbe in the circulation, and thromboinflammation is more or less a more general process of inflammation in response to an initial inflammatory stimulus. C'est un peu suivante. Thank you. Okay, so let's start for the very beginning, and what I propose to you is to understand immunothrombosis or thromboinflammation with the first activation of platelet. They are the main role, the initiative event of thromboinflammation, and this is, mainly related to the binding of P-selectin on platelet here, for instance, with the monocytes and the leukocyte. This is really the first event that is going on when we consider a mechanism of thromboinflammation. Diapositive suivante, thank you. And then again, you have two different way or pathway that are stimulated. The first one is the one on monocyte here. So the platelets are activated, the monocytes are activated, and the activation is not, NF-kappa B dependent. It's more or less inflammasome, an NLRP3 inflammasome, which is involved in the activation of monocytes, and the activation of these cells. They release cytokines, they release tissue factor for the coagulation and the inflammation respectively. And on the other side, the interaction of activated platelets on leukocytes are leading to a very, very special event, which is called is neutrophil extracellular trap release. It's just like, the cell is open up and release the content in the nucleus of the cells, in the cytosols of the cells, and you can see here what we call DNA, histone, and different kind of antimicrobial proteins, such as the very well-known myeloperoxidase or the very well-known elastase. And associated with neutrophil activation, the leukocyte is also involved in endothelial activation. Diapositive suivant, thank you. Okay, and the other thing that is very, very specific to thromboinflammation is the activation of this system, which is called contact system, Ashman factor, with the kallikrein-bradykinin pathways. And this is important because it's really a pathophysiologic link between coagulation, contact factor 12, and inflammation by the interaction of kallikrein-bradykinin system. And when the bradykinin is present in the circulation, then this molecule can bind to some kind of very specific receptor, bradykinin receptor 1, bradykinin receptor 2, and this receptor binding is accompanied with the stimulation of the inflammatory signaling cascade, endothelial cell injury, and also something which is very, very common in Botrop's local effect, which is edema formation due to capillary leak induced by the binding of bradykinin to receptor 1. So this could be the slide that try to summarize what is going on in thromboinflammation. I told you about P-selectin, platelet activation with P-selectin, neutrophil and monocyte activation through the NLRP3 activation, coagulation activation, bradykinin activation. So now the question which is answered on this slide is how the thrombus is made. How does it work? I try to explain now. This is the Villebrand factor here, and this is the neutrophil. These are the monocytes, which are activated by the platelet. And again, you have to understand that the platelets are probably the initial event leading to that. And the formation, the thrombus formation, is considered to be an interaction between ultra-large Villebrand factor string, so like string, and there are the scaffold for thrombus. And this scaffold is associated with nets, neutrophil extracellular trap, platelet, and the inflammatory of the endothelium. So this is the way actually the people who are dealing with, very, very deeply pathophysiology on thrombosis are considering nowadays the thrombus formation. Okay. So the last part of my talk is now to convince you that at least part of the thrombotic event that we are seeing in the Botrop's SP Envenoming could be linked, at least more or less, to thromboinflammation. So this is a simplistic scheme of what could happen with net formation, monocyte and leukocyte activation, platelet activation, etc., just as I told you. So the first paper dealing with this is a paper from the group in Manaus, Brazil, your group, right? And it was very interesting, and the reason was because it was the first to try to understand not only inflammation on the one side, coagulation on the other side, but try to mix, to think about the interaction between the two. And they see that, I won't go deep into the paper method, but the message is that in the case of normal patient with normal fibrinogen, and in the case of hypofibrinogen, considering that hypofibrinogen is, thank you, is associated or mean, coagulation perturbance, then the network correlation between the different cytokines or the different chemokines are quite different. And this was the first idea, I think, considering that there is some interaction between coagulation and inflammation. Inflammation is doing something on coagulation, coagulation is doing something on inflammation, and the turn is turning, if you made this expression. Yeah.
2 minutes.
Yeah, thank you. So just, okay. So my conclusion on that, because I have not so much time, is that in thromboinflammatory, the thrombotic event could be related to that weak procoagulant effect, which is associated with a consistent systemic inflammatory system. Secondly, that the systemic response appears to be more intense in Botrop lanceolatus when compared to other botrops such as Atrox. Many of the specific thromboinflammation process are really present in the feature of the biologic response to lanceolatus. And I think this is my last message, and I think that the better understanding of this thromboinflammation could lead to new therapeutic strategy that could be tested in our patient. And there is in a huge literature, not of course in envenoming botrops or snakebite envenoming, but a huge literature when you are considering a stroke, for instance, cerebral stroke, and they are using a lot of different pharmacology compounds, such as monoclonal antibody. So I just finished my presentation. I'm not sure I gave you the right message. I had the impression that it was too long. Sorry about that. But I'm open to any question of the audience, of course. Thank you.
Thank you very much, Remy. I think for the sake of time, we will wait for the questions to the end of the session. Okay? Thank you very much, Remy. So our next presentation is by Professor Hatem Khalel, who is going to speak from French Guiana. Jonathan, is he? Okay. And the topic of his presentation is snakebite management in intensive care unit. Welcome, Hatem.
Yes.
Okay. Welcome, Hatem.
Yes, we can. Try to say something now. Try to see something. So we can test the sound. Go again. That's great. That's the thought.
Doesn't work?
Keep trying.
Good morning. Hello.
Nobody's hearing. No.
Hello.
Nobody's hearing.
Hello.
Yeah, go ahead. You can go ahead.
Yeah, it's okay?
Yeah, go ahead. Yes.
Ah, they can hear me. Okay. Do you see my screen? Do you see my screen?
Yes, we can see your screen.
Okay. Yes. So, good morning. First of all, I would like to thank the organizing committee for inviting me and for giving me this opportunity to give this talk. I would like also to thank Professor Rezier and Professor Guterres and their teams for their involvement and their commitment in tackling snakebite envenoming in the region and in the world. Snakebite envenoming is a global problem affecting disadvantaged and vulnerable population. It is an overlooked topic which is responsible for several disabilities and a lot of mortalities. It was described by Mr. Kofi Annan, the former United States Secretary General and Nobel Prize for Peace, as the greatest public health crisis you have never heard of. Recently, with Professor Rezier, we published a letter in Toxicon where we describe snakebite envenoming as a typical example of social and ethnic inequity in medicine. And we emphasize that ethical considerations are imperative to improve antivenom accessibility and snakebite envenoming management. Philip Berg and his team published in Nature Communication this year also a letter on snakebite envenoming in Africa. They say that it remains widely neglected and demands multidisciplinary attention. And this is the case also, I think, in the Caribbean and in the Amazon region. They emphasize that imbalance of public health burden and funding in comparison to other diseases of concern, where we can see that funding is most drive to HIV, AIDS, malaria, but not enough to snakebite. So let's return to our topic. Our topic is about French Guiana, and French Guiana is an overseas department or region of France located in South America, and it is bordered by Brazil and Suriname. It covers a total area of 84,000 kilometers square and home to approximately 300,000 people. French Guiana is home to many ecosystems like the Amazon region, and it is covered by the Amazon rainforest. In French Guiana, there is 3 main hospitals and 18 remote healthcare centers. Antivenom is available only in hospitals. And most of time, people are transferred from remote healthcare centers to hospitals to receive antivenom. And this transfer is made by helicopter, and it take the one-way travel will take 1 hour to 1 hour and a half. This is why the time from snakebite to antivenom can be very long, and sometimes it is even delayed further because patients have to walk in the forest, or they have to travel with a boat to attend the nearest healthcare center. In 2017, the first international symposium on snakebite was held in French Guiana, and we designed and addressed some action like how to grade the envenoming and what we have to do and not to do in the file, and how we use antivenom and antibiotics. Indeed, in French Guiana, there is almost 100 snakebite per year, mostly caused by Bothrops atrox. Half of the patients first attend a healthcare center before being transferred to the hospital. And in Cayenne Hospital, we manage approximately 35 snakebite envenomed patients per year. Those patients are hospitalized in intensive care unit, and this is our choice. Not all of them need intensive care management, but our choice in our hospital to admit them to ICU and to deliver treatment there. And treatment and management will focus on painkillers, antivenom, hydroelectrolytic management, management of kidney injury and kidney failure, and antibiotics. So I will focus more in this talk in antivenom and antibiotics. So the antivenom used in French Guiana is the antivitamin 3, which is manufactured by Bioclone, and it is polyvalent immunotherapy. In 2020, with Professor, we published the first study on the assessment of the efficacy of this antivenom, and we found that patients who receive antivenom took a shorter time to recover from coagulopathy. But as we can see, the time to antivenom is very long, and this is just an average of delay. Regarding, so in my next talk, I will speak about antivenom more in detail. Regarding the kidney, snakebite is responsible for edema, third sector, hemorrhage, hypovolemia, rhabdomyolysis, hemolysis, and hemolytic and uremic syndrome. Patients can present with normal renal function, or they can present with renal injury in 17% of cases in French Guiana, and the main management is to administer fluid to compensate hypovolemia. In 1/4 of cases of patients with renal injury, they will progress to anuric renal failure, and 1/4 of them will need hemodialysis. Regarding infection following snake bite range from 9 to 77% in the international literature. And the first question we have to ask in a patient consulting after snake bite, should we administer prophylactic antibiotic, and what is the drug to administer? In many studies, amoxicillin clavulanate is administered to prevent infection after an animal bite. But recommendations are based on studies involving dog, cat, and human bites, but not snakes. In our experience, in our hospital, 1/3 of cases of patients who present to hospital after snake bite receive amoxicillin. Jacqueline Sachette explained very well in a randomized controlled clinical trial that there is no benefit. With Profresier also we published this letter. Which emphasize this information, empirical amoxicillin clavulanate, the lack of specificity. Probably this explains why the range of the prevalence of infection is very large in the literature. In 3 papers from French Guiana, Martinique, and Brazil, infection occurred in 58 to from 5 to 58%. And to document infection, we had to perform blood culture, soft tissue sampling, skin sampling, and only the culture, the isolation of the microorganism can give the confirmation of the infection. The main isolated microorganisms are Aeromonas hydrophila and Morganella morgani. Surprisingly, the same microorganisms are the main bacteria isolated in the mouth of snakes, Botrops lanceolatus in Martinique. Also, Aeromonas species are common waterborne organisms that are involved in necrotizing soft tissue. So sometimes the necrosis after snake bite can be either caused by the venom, but probably the Aeromonas hydrophila can contribute to this manifestation. In 3 studies, 2 from Asia and 1 from French Guiana, the microbiological testing of Aeromonas hydrophila show a susceptibility to 3rd generation cephalosporins that can be used as first-line antibiotics. So in a very recent editorial that we published in the American Journal of Tropical Medicine and Hygiene with Professor Dabor, we recommended as first-line antibiotics 3rd generation cephalosporins, piperacillin, tazobactam, fluoroquinolones, or clindamycin. Now, when the microbiological results are available, sometimes we have to switch the drugs, the antibiotics, to the narrowest spectrum one. And the antibiotic duration, there is no formal recommendation, but it is about 5 days. However, some unresolved issue in antibiotic management following snakebite are need to identify at-risk patients, need to, for a core set criteria to diagnose wound infection following snakebite, place of biomarker to give the diagnosis, appropriateness of procalcitonin as a marker of wound infection following snakebite, and the duration of antibiotic therapy. There is no formal answer in the literature about this. In conclusion, management of patient victims of snakebite involve the early use of antivenom, fluid infusion. We have not used amoxicillin clavulinate. It is not appropriate as preemptive empiric antibiotic after snakebite, and the most recommended first-line antibiotics are third-generation cephalosporins, piperacillin, tazobactam, fluoroquinolones, and clindamycin. Thank you very much.
Thank you very much, Professor Paquet. As that already been said, to put the question at the end of the session, it's now my pleasure to welcome Professor Gutierrez. Please, Professor. So we speak about management of snakebite envenoming in America.
So, as we all know, snakebite envenoming is an important public health problem in our region. In this paper published by Jean-Philippe Chipot, based on data from the Ministries of Health, the number of envenomings is about 57,000 cases in our region with 370 deaths. But these are data coming from the Ministries of Health. It is very likely that the number of cases and the number of fatalities is much higher than that. And in our region, as we know, the snakes having the highest impact belong to the genus Bothrops, and in South America in particular, in some parts of Central and North America, Crotalus, with few cases inflicted by coral snakes, 1 to 2% of the cases. Next one. So our region has a long tradition in research, antivenom production, and clinical management. It started in Brazil with the work of Vital Brasil Mineiro da Campanha, who developed the first antivenoms in the year 1901, and then published this iconic book, A Defensa contra Ofidismo, A Defense Against Ofidism, in the year 1911. And then other people in our region, like Clodomiro Picado in Costa Rica, also did significant work in the first decades of the 20th century. And several institutions in our continent have devoted a lot of attention to the problem of snakebite, such as Instituto Butantan in the upper left, Instituto Malbrán, Instituto Clodomiro Picado, and we have had many collaborative efforts in the region shown here by this meeting in Instituto Butantan with people from antivenom producing laboratories. So our region has a tradition, has expertise, and this is very important to the efforts being carried out at this time. Next one. So in the decade of 2000, and with the support of the agency CITED, the Japanese International Cooperation Agency, and FEMCIDI from the Organization of American States, we were able in Latin America to build a network of antivenom manufacturing laboratories from the public sector, including laboratories in Mexico, Costa Rica, Venezuela, Colombia, Peru, Bolivia, Brazil, of course, and Argentina. So this network started doing work in the early days, the early years of the decade 2000, and achieved significant advances in this field. Next one. For example, we developed several workshops to discuss the situation of antivenom production in the region, the situation of antivenom distribution and stability and accessibility, and also through this regional effort, we carried out perhaps the largest preclinical study on the efficacy of antivenoms in our region, evaluating antivenoms produced in 6 Latin American countries against several bothros venoms. And fortunately, the conclusion of this study was that antivenoms in the region are very effective and have a high degree of cross-reactivity, so that antivenoms manufactured in one country can be used in other countries. So this was a very positive regional cooperation. There were technical exchanges also, many consultations from antivenom producing laboratories, and training of technical and scientific staff. Next one, please. So, like I mentioned yesterday, in the last decade, there were significant advances at the global level. In the year 2017, the World Health Organization included the snakebite envenoming in the list of neglected tropical diseases. In the year 2018, the World Health Assembly approved a resolution proposed by Costa Rica, Colombia, Brazil, and 20 other countries to address the problem of snakebite envenoming and to urge ministries of health and authorities to take actions on this. And then in the year 2019, the World Health Organization issued for the first time a global strategy to confront and prevent snakebite envenoming based on 4 pillars: safe and effective treatments, empowering and engaging communities, strong health systems, and partnership, coordination, and resources. Next, please. So, on the basis of this mandate from the World Health Assembly and the World Health Organization, the Pan American Health Organization, through its department PANAFTOSA, based in Brazil, took the lead in the regional efforts to confront the snakebite envenoming and develop a series of activities which I will describe. Next one, please. One thing was to consolidate the network of public antivenom manufacturing laboratories, as this was done in a meeting in Sao Paulo, in Butantan, in the year 2018, with the official and formal creation of RELAPA, which is the network of public antivenom manufacturing laboratories in Latin America. And as you see, there are laboratories in all the countries I mentioned before. So with the support of the Pan American Health Organization, with the coordination of PAHO, this network, RELAPA, started to do significant work in the region. Next one. One of the main activities of RELAPA has been the diffusion of the guidelines, of the WHO guidelines for the production, control, and regulation of antivenoms. These guidelines, which were initially issued in English, were translated to Spanish by a colleague from Instituto Clodomiro Picado, Gabriela Solano, and this is the publication. This publication has been made available to all the antivenom manufacturing laboratories. And next one, please. So in these RELAPA efforts, we have done webinars on the WHO guidelines, inviting people from all the antivenom production laboratories, that are very productive webinars. Next one. We have continued the preclinical evaluation of antivenoms. Now this is an ongoing project with 4 laboratories evaluating different antivenoms in the region against different venoms. We have provided support to the Ministries of Health, which have requested support ministries of health from Peru, Ecuador, Guyana, Paraguay. Different actions have been performed with these organizations. We have provided technical support to manufacturers to improve the quality, the standards of the antivenoms, and we have also had meetings with focal points of the ministries of health. So the idea with the WHO global strategy is that in every ministry of health there should be a focal point or a department following up on snakebite envenoming. So RELAPA has also promoted these meetings with focal points, all of them coordinated by the Pan American Health Organization. Next one. So for example, I would like to mention these webinars that we have performed, 9 technical webinars attended by 500 participants on the different chapters included in the WHO guidelines for the production, control, and regulation of antivenoms, in topics such as snakes and venoms, veterinary care of horses, immunization schedules, purification of immunoglobulins, and so on. All the sections in these guidelines have been covered in these webinars aimed at the technical staff of the antivenom manufacturing laboratories. Here I show an image of one of the workshops, webinars given by our colleague Aaron Gomez on the maintenance of a serpentarium. And all these webinars are available in this web page of the Pan American Health Organization, PANAPTOSA, and RELAPA, where you can follow up all these webinars. They are available there. Next one. Also, we have provided in this phase technical support to ministries of health and workshops to health staff. In March of this year, we had a very interesting activity in Guyana. Guyana requested this to the Pan American Health Organization, so we visited Guyana to give a workshop on diagnosis and management of snakebite envenoming. And similarly, we have provided webinars on diagnosis and treatment of snake bites in Peru, Paraguay, and Ecuador with a large attendance of physicians and nurses from these countries. Next one. Also, at the PANAPTOSA, we have been present in the International Awareness Day about snake bites. So, in the last years, there has been in the September 19th, it is the International Awareness Day for snake bite. So many communications move along all over the world, and the Pan American Health Organization has also participated, as well as several of the institutions belonging to RELAPA, in this Snakebite Awareness Day. Next one. Likewise, materials for prevention of snakebite, on how to avoid snakebites, how to act in the case of a snakebite, have been also prepared, published, and widely distributed. Next one. So, on the basis of these advances and this progress carried out by the RELAPA and APAHO initiatives, we proposed a project to the Wellcome Trust in the United Kingdom to continue and to consolidate these regional efforts in Latin America and the Caribbean. And the project is named Towards an Integrative Approach to Improve the Management of Snakebite Envenoming in Latin America. And it was, fortunately, approved and supported by Wellcome. And this project is just started right now. Next one. This project has 3 main objectives. The first one is to consolidate RELAPA as a network of antivenom laboratories. Next one. So for this, we are planning to do technical meetings and webinars, to follow up with the webinars. Next one. To do strategic meetings with authorities of institutions to ensure that the authorities are committed to support this program. There will be technical exchanges and advice to manufacturers so that the overall quality of antivenom manufacture in the region can be improved. Next one. And there will be a catalysis for the distribution channels of antivenoms in the region with the epidemiological information. This project will try to promote a more effective antivenom availability and accessibility in the region. Next one. And we aim with this first objective to generate qualitative and quantitative improvements on regional antivenom manufacturing and quality control. So this will be the first objective of this project, to strengthen the regional capacity to produce safe and effective antivenoms. Next one. The second objective is to the development of regional guidelines for the diagnosis and treatment of envenomings. This is well advanced, it's almost finished, it's now under evaluation by colleagues in the region. And these guidelines were developed based on the WHO guidelines that have been issued for Asia and for Sub-Saharan Africa, so to keep the same style, the same structure, the same organization, of course, being adapted to our region. Next one. So with these guidelines, they will be published both printed and online. And with this guideline, we are planning to create an open, interactive virtual course for the management of snakebite that can be used all over our continent. And also, it is planned to have in-person workshops for health workers in 14 countries in close coordination with ministries of health. So this will be very important because these seminars will be like this one here, will be aimed to physicians and nurses in 14 countries in the region to strengthen their local capacities to diagnose and treat snakebite envenoming. Next one. And the third objective will be to strengthen the network of representatives of the ministries of health in charge of the snakebite programs in each country. It is very clear that the success of any effort to reduce the impact of snakebite will depend on the political commitment of the ministries of health. And no matter how many general statements and instructions and plans are developed at the high level, in the long term it is the political will of ministries of health that will take these ideas and will move them in the country. So this project also aims to strengthen the network of representatives in each country and to develop coordination with and between ministries of health to gather robust information on incidence, mortality, and regions of higher risk, to have reliable information on antivenom needs, and to consolidate national strategies for prevention and control. Next one. For example, at this point, it is, the idea is to develop a uniform form to collect information on snakebite envenoming. Some countries like Brazil, for example, Costa Rica, have a good base of information on the number of cases, complications, fatalities, and so on. But in many countries, this information is very limited. So this project pretends to have this uniform way to get information about snakebite incidents, mortality, sequela, and so on. Next one. So in the long term, we aim, and this project aims to have to build a multi-sectorial and international partnerships, including antivenom manufacturers, ministries of health, the research community, the Pan-American Health Organization, which coordinates these efforts, and of course, health workers trying and dealing with snakebite envenoming. Next one. So this work is being led, as I mentioned, by the Pan-American Health Organization, specifically by the Department Panaftosa, by Marco Vigilato, Felipe Rocha, Larissa Sanet, Julio Pompey, Otorino Cosili, and Dr. Fan Wing from Instituto Butantan and myself. We have provided technical support to these initiatives, but the most important thing is that it will be a cooperative, multi-sectorial, multi-country effort, including stakeholders from all the countries in our region, in Latin America and the Caribbean. And as I mentioned, this project is being supported by WELCO. So with this, I thank you very much for your attention, and I look forward to any question or comment you have at the end of the session, right?
Yeah, thank you very much. So it's now my pleasure to welcome Dr. Hagani, in charge of the presentation, is that natural conservative venom has the potential to induce fungus formation during envenoming.
Good morning, everybody. First of all, I want to thank Professor Labor to allow me to take part of this conference. So today I will try to ask the question if the Botropson ciliatus venom have the potential to induce thrombus formation. Based on our study, the contrasting effect of Botropson ciliatus and Botrops atrox venom on procoagulant activity and thrombus stability under blood flow conditions. Next. So when we talk about thrombus formation, we have to talk about coagulation factor. So here we have two coagulation factor and the activation of platelet. The coagulation factor, it's a set of 13 coagulation plasmatic factor which can be activated here. We have two pathways, intrinsic pathway and extrinsic pathway, and all of them tend to activate factor 10 and the purpose of this thrombus formation is to stop bleeding after. Thank you. Is to stop bleeding after a vessel breach. Next, please. Despite of the fact that Botropson ciliatus venom has the similar composition comparing to other botrops, but Botropson ciliatus venom lead to thrombotic complication at the arterial side of vasculature. However, when we look to the studies in the literature, we have conflicting results in the studies. Some studies concluded about a procoagulant effect of Botropson ciliatus, and some articles conclude of non-procoagulant activity. So, in our work, we assess this thrombus formation under a high shear rate, mimicking arterial blood flow and physiological condition. Next, please. No, the aim of this presentation is, of course, to ask the question if Botropson ciliatus can promote thrombus formation, and for that, I will answer 3 questions. If Botropson ciliatus has a procoagulant effect in vitro condition, is it able to activate clotting factor? And the third experiment will be about thrombus formation under a shear stress condition. Next part. So for the first experiment, it's about incubation of the plasma and the venom with the buffer with calcium in physiological condition, and or fibrogen with the same buffer in the presence of calcium. So the plasma with the venom and calcium will promote fibrin formation. This fibrin formation will induce opacity of the medium, and which can be followed by the optical density at 405 nanometers. Next. The second experiment is about the evaluation of coagulation factor activation by using chromogenic substrate. Chromogenic substrate here is in green. It's a specific sequence peptide which is linked with the colorless chromophore. When this specific sequence peptide are cleaved with the corresponding coagulation factor, the chromophore will turn to yellow, and this color will be followed by optical density at 419. But in this experiment, we have to consider two effects: the effect of the venom on the coagulation factor in plasmatic condition. So here. So the snake venom enzymes can activate coagulation factor, which in each term will just activates this specific sequence and leads to enhancement of yellow color. But the snake venom itself can directly activate this specific peptide, because snake venom can act as coagulation factor can have this activation. So the second part of this work was to test this chromogenic substrate on coagulation factors purified. Next. And the third experiment is about thrombus formation analysis in flow condition. And for this experiment, we use a TTAS technology, which is a technology which uses microchip fluidic chamber system here. And it uses mineral oil and pumps. It pumps oil in this tubular, and blood will be forced in the capillary, which is coated with the collagen 1 type 1 and the T-cellular factor. So here, when the thrombus will be formed, we can, every pump have a highly pressure sensor, which can record the pressure in return. Okay. So for the result, there is something missing here. Okay. On voit pas tout bien. There is something missing. So for the results, for plasma clotting activity, maybe you can next. Okay. So for plasma clotting activity, here the use of plasma with calcium induce a fibrin formation open 8 minutes of time. So when we use blood venom at concentration, at the variation of concentration, we can notice that the fibrin formation came earlier. The time to have the maximum of fibrin formation is inversely proportional to the concentration of the venom. When targeted fibrinogen clothing activity, here when we use the high concentration of Botrytis ciliatus venom of about 100 microgram per milliliter, we can observe that the fibrinogen can be clotted open 20 minutes, and when this concentration is decreased, the clotting activity come at 5 hours after incubation. So the Botrytis ciliatus venom can clot the purified human fibrinogen. Okay, here the evaluation of the activation plasmatic coagulation factor by Botrytis ciliatus. We did 2 experiments with the plasma condition, as I explained. It take into consideration the 2 pathways, and the other side we use just a buffer with snake venom and the peptide and specific peptide. And we can notice in the presence of a plasma, we have an activation or a cleavage of specific sequence of prothrombin, of prekallikrein, but not for factor 10. When we assess this activity of the venom without plasma, we can see that the venom can itself cleavate the specific peptide of prothrombin and prekallikrein. So we can notice that our Botrytis lancelliosis venom have a thrombin-like and kallikrein-like enzyme. Okay. To confirm this effect to confirm this effect, we use the same experiments on purified factors. So here we use the prothrombin, human purified prothrombin, and human purified factor 10. And as we can notice, Botrytis lancelliosis can slightly directly activate prothrombin, but it didn't activate factor 10. The last experiment is about thrombus formation in the underflow condition, and this is a kind of curve we can observe. It's an exponential curve. We have three parameters to consider. The first parameter is the time to have 10 kilopascal of pressure. And the second parameter is the time to have 60 kilopascal of pressure. It's about occlusion time and occlusion starting time. So here, it's our results. So in green, we have our control. We can see that our occlusion starting the time is about 7.5 minutes. When we add our Botrytis lancelliosis venom at 100 nanograms per milliliter, we can observe that our time to start occlusion is earlier. Okay, but our time to come to all occlusion, to total occlusion, is exactly the same of control, comparing to control. So we can, here to explain this difference, we can just focus on the time to have 10 kilopascal of pressure, and the time elapsed between 10 and 60 kilopascal. And we can observe that there is a drop in the pressure. This drop in the pressure is the consequences or the fragility of the thrombus formed. So here when we use variable concentration of venom, we can notice that our OESTs, so the time to initiate the thrombus, is smaller. The time elapsed between T10 and T60 kilopascal. When we add Botrytis lancelliosis venom at a high concentration, this elapsed time increases. So the stability of our thrombus is decreasing. So the Botrytis lancelliosis can initiate thrombus formation, but this thrombus didn't resist to shear stress. So in conclusion, we can say that the Botrytis lancelliosis can induce fibrin formation in the presence of calcium. It can increase activation of prothrombin, slight activation of prothrombin, and and have a prekallikrein activity in vitro condition. It can initiate thrombus formation under shear stress with to marked fragility, and it have a prekallikrein-like activity which can link between thromboinflammation and immunothrombosis system. So we thank you for your patience, for attention.
Thank you very much, Dr. Faveli, for this presentation. It's time to go to the audience and see if there are any questions to the different speakers. If not, I will ask a question to Professor Ritchie. As you mentioned that there is a lot of cross-reactivity from country to country. Is that true for all the snakes, or is there some snakes that are more or less sensitive to local, you know what I mean?
Yes. Well, in that study, we only evaluated Bothrops venoms. Bothrops jararaca from Brazil, Bothrops naturs from Peru, Bothrops naturs from Colombia, Bothrops asper from Costa Rica, Bothrops santogramus from Bolivia. And all of the antivenoms that we tested, which were from Peru, Bolivia, Brazil, Argentina, Costa Rica, Colombia, and Mexico, they cross-reacted very well against these Bothrops venoms. So the conclusion is that despite the fact that in proteomics there are differences in Bothrops venoms, in terms of immunogenicity of the toxins, they are very similar, fortunately, because every antivenom is made with different venoms, but the neutralization was very good in general. In that study, we tested neutralization of lethality, hemorrhage, myonecrosis, in vitro procoagulant activity, and in vivo defibrinogenating activity. So we are pretty sure that the antivenoms cross-react widely for both those venoms, and for this particular both those venoms. So we need now, we're in a phase where we're introducing more venoms in the study, and including rattlesnake venom, Crotalus, which have differences between South America and North America, and we'll see whether this cross-reactivity maintains or there are differences. But the results are very encouraging.
Is there any question?
Good morning. Thank you for the presentation. They were very interesting. I just want to find out if in relation to St. Lucia, the furtherance that we have, and since it's supposed to be similar to that of the water, will we have the same presentation in the terms of inducing fungus formation?
Thank you. From the literature, I think there is only 2 papers dealing with this specific issue, so it's not so easy to answer the question. But from what is coming from the clinical world, it seems like the clinical presentation is very, very similar between conservatives and cannabis. I understand correctly to your question. Is that correct? Okay, thank you.
If I may add to this question, when we analyze the venoms by biochemical analysis and toxicological analysis in mice, they are very similar, Bothrops lanceolatus and Bothrops caribeus. So it's very likely that the clinical presentation is also similar. Mm-hmm. I have one question for Professor Navier. So what? In this in vivo model that we are trying to develop, in order to follow this hypothesis of thromboinflammation, which anti-inflammatory agent would you recommend to test this hypothesis?
Okay. I will not answer your question directly, of course, but from my point of view, I'm a critical care guy. And my surprise was in the therapeutic therapeutic for sepsis, all the anti-inflammatory drug that has been tested so far, the clinical trial gave no result, no difference between the treatment group and the control group. So I'm not sure about the way to follow with anti-oxidant or anti-inflammatory drug will be
the way.
the way to go.
You don't think corticosteroids would do it? No.
No.
Thank you.
Any other question?
There. Well.
Any question? Would you say yes?
Welcome.
Dr. Montero?
To Dr. Nene. Excellent presentation.
Thank you.
We see in Botrops Zytrox envenomations that platelet levels, platelet counts decrease even after the antivenom treatment, and lowest values of platelet counts occur in 2 days after the antivenom treatment, after the hospital admission of the patient. And also the microangiopathy, thrombotic microangiopathy, appears the onset of the clinical signs, high bilirubin levels, or the appearance of the slides of the schizocytes. Also at this time, 24 to 48 hours after the antivenom. Antivenom is not protecting, in your opinion, of the in relation of these manifestations, clinical manifestations, or any specific toxin there is not neutralized by the antivenoms.
Okay, so far I understand exactly what you asked. There is two, from my point of view, there is two things that you have to consider. The first one is the effect of the venom of the different cell types. But there is also another parameter that you have to consider, is the natural production of these cells. And this is extremely important for the platelets. So this is the first part of my answer. The other one is, again, at what time are you considering the patient? And again, from the critical point of view, the critical care point of view that we have, if you don't have any information about the immune system response, you may not draw any hypothesis on treating the patient correctly. If you don't have, and I know it's difficult because it's exactly the same thing in critical care medicine. We do not have so much tool to evaluate the intensity of the immune response. Could be high, could be low, and if you put anti-inflammatory drugs when the response is very low, it's not usual. So it's kind of difficult to answer the question, but again, from a biologic guy as I am, you have to consider at least two parameters, the natural evolution of the venom in the blood, and also what the cells, what are the half-life of the cells, and how fast the production of new cells are produced.
May I comment on your question, Welton? I found it very interesting from a thesis from your group that thrombotic microangiopathy develops later on, once the clotting factors recovered after antivenom treatment. So my interpretation, this is hypothetical, of course, speculative, is that there is some damage or stimulus to endothelium to become more procoagulant. This doesn't have an effect when the person is defibrinogenated. But when the antivenom controls the procoagulant enzymes and then the liver synthesizes clotting factors, then at that point the endothelium is perhaps proactive and procoagulant. And that's the time when the thrombotic microangiopathy develops. So this is an hypothesis, but I think that may be the case. So it would be really interesting to investigate what goes on the endothelium in terms of changing the phenotype to a prothrombotic or pro-inflammatory endothelium in these cases.
Any other? Okay, so it's time to conclude.
time.
And to thank the audience for invitation and also the different speakers. Thank you very much. And
So Tabor, now we go to a coffee break. For how long? Because we are a little bit behind. 10 minutes. Okay. Okay.
hear me better? Yes. Okay. He's going to talk about management of snake envenoming in Amazonian Brazil. Is Dr. Welton Marcelo Montero, who is a very, very smart and expert in the field of snake bite envenoming. So we are glad to have him. Last year we tried hard to let him come to Martinique, but he didn't come. So there is no difference. I think St. Lucia is beautiful, Martinique also is the same. So, Professor, thank you very much. Brazil.
Okay, it's possible to hear this distance? Okay. Good morning, everyone. It's a pleasure to be here with you in this fantastic country that I loved when I arrived in the airport. Fantastic people that I know so far. Thank you so much, Dr. Dabur. You are my friend of the heart, okay, from my heart, or friendship yet, okay? And I am most grateful to you for this invitation and opportunity to know this, as I said, this wonderful country. I have been following your publications, your works you are developing here, and you are doing a fantastic work, okay? My objective in this presentation is to briefly review the situation of snake bites in the Brazilian Amazon and the plan to decentralize antivenom treatment, especially to indigenous communities we are performing there, okay? The title of my presentation is Management of Snake Bites in the Brazilian Amazon. I don't know if you are expecting that I will talk about clinics, but I will talk more about implementation science than clinics, okay? Next. Okay. In the Amazon region, the incidence of snake bites are around 50 cases per 100,000 inhabitants. This is 5 times higher than in the extra Amazon of the country. 90% of the envenomations in the Amazon region are caused by our jararaca. Jararaca is the Botrops atrox that is a relative of your Botrops lanceolatus and Botrops caribeus. The costs per year of snake bites in the Amazon per year is $8 million, including the perspective of the health system and in the perspective of the society regarding, for example, the days of work, losses of work, working days, and people that die yearly in their lives because of the envenomations. Systemic complications are mostly represented by systemic bleeding in 15% of the patients, acute kidney injury in 10 to 15% also, and thrombotic microangiopathy in 10% of the cases. Local complications, secondary bacterial infections in 40% of the patients, and permanent disabilities in around 5%. Case fatality is around 0.6% of the cases, and risk factors for fatalities are time to care higher than 6 hours from bite to medical treatment, elderly, indigenous status, lack of antivenom administration. Causes of death are related to acute kidney injury, acute respiratory failure, sepsis, circulatory shock, systemic bleeding, including hemorrhagic strokes, as mentioned by Professor in the previous presentation. Next. Here, I will not spend much time here because Jacqueline explained yesterday about the clinical part, but we have hemorrhagic complications causing the systemic manifestations of the disease, then coagulation disorders. Then you see bleeding in every part of of the body is possible, including in the central nervous systems, and this is causing fatalities in our population. In in the limb affected, we see necrosis, we see edema, we see pain. If there is envenoming, we see pain and edema, but that can complicate with necrosis, including extensive necrosis, leading to amputation and compartment syndrome. Next. In Brazil, we have 4 producers, antivenom producers, and in the case of snake bites, we have 5 types of antivenoms for botrops, a combined botrops lachesis, that lachesis is the bushmaster, crotalus is the rattlesnake, botrops crotalus, the combination, and the micrurus, that coral snakes. Then we have 4 genera of snakes causing envenomations in our country. Antivenom in Brazil is provided free of charge for the patients, only in the public hospitals, provided in 2,200 hospitals across the territory. Okay, then antivenom is produced today only in São Paulo by the Butantan Institute. Is distributed by the 27 states of the federation, and from the capital of each state, we name state, for the municipalities in the interior of the state. Okay, my state is. This is the Amazonas state, is the biggest state in the Brazil, and we have in this state 62 points of treatment using snake bites, only in urban areas. This is a problem of access to rural populations and for indigenous populations. Okay, antivenom distribution is linked to epidemiological surveillance. Each case of snake bite is reported in a standardized form by the health professional in the micro level of the epidemiology system in the hospital, and this is informed to the state and to the federal level that plans the acquisition of antivenoms for the next year based on this average use in the last 3 years. Please. Here we see a problem, especially for the indigenous population. We see 3 boys that developed severe long-term disabilities caused by the compartment syndrome related to delay in antivenom administration because of the problem of geographical barriers to arrive to the hospitals for this indigenous population. Then we see here scarring, muscular atrophy, amputation affecting the mobility of these kids. The persistence of these disabilities obviously impact a lot a life of a children. Imagine the cognitive impairment, the social impairment, and including this child, for example, are in the school activities, and most of them suffers from stigma and prejudice from the colleagues, for example. This is a lot of, there is also a social problem in our communities. Next. Here we see the organization of the indigenous health system. In Brazil, we have we name SUS, a unique public health that is universal, but in terms of coverage, is not so. There are inequalities, especially for populations living in remote areas. We see we have a subsystem that is responsible to provide care to the indigenous populations. We have in Brazil today 1 million self-declared indigenous individuals in the Amazon region. Then the incidence in these populations is 6 times higher than the rest of compared to non-indigenous populations, we saw in the beginning of the presentation 50 of incidents per 100,000 population, and here we see 333 cases of incidents in indigenous villagers. Okay, here we see that we have the primary health communities in indigenous areas, but they don't treat and they don't have antivenoms in these primary care units, and this is responsible by disproportionate frequency of lethality and late medical assistance and consequent lethality from snake bites in Amerindian indigenous populations. We see here, for example, the lethality is 1.5% compared to 0.5% in populations living in Manaus region in the urban area of the state. Next. There is also a problem in terms of underreporting. Underreporting is very frequent in the Amazonas region because to be reported, the case need to arrive to the hospital to receive treatment, receiving treatment, the professional feel that standardized form that I mentioned to you. And here we see, for example, that in some communities, in some basins, in some river basins, that the proportion of patients that were bitten by a snake and did not arrive to the hospital and did not receive it, a notification, the system did not receive it, the notification of the cases. In this here, we see the Juruá region of the state that 75% of the cases that occur in that region did not receive medical attention. This is very high frequency, and this needs to be addressed in public health intervention studies. Next. Now I will start to explain a project that we developed. It is named Saving Snake Antivenom Immunoglobulins Need to Be Guaranteed. It was funded by the Brazilian Ministry of Health and by National Institutes of Health, the NIH. I coordinate this project with Dr. Jacqueline, and we are finishing this project now, calculating the indicators of efficacy and cost effectiveness of this program of decentralization. The project had the aims of develop a decentralized antivenom distribution program optimized by geographic location of the cases reported to the systems and the community health facilities in the low resource areas, especially indigenous areas, conduct a formative intervention using a culturally relevant snake bite care package, conduct an economic evaluation of various of the variants of the model of the decentralized antivenom delivery, actually various models of decentralized antivenom delivery, and implement decentralized antivenom distribution program in the indigenous community health centers. This is, here are more detailed the objectives of the studies and the respective methodologies employed. Next. First of all, we needed to organize the program, including people from the indigenous districts, the Brazilian Ministry of Health, and the state authorities. Then the indigenous leaders of the indigenous areas of the Amazonas state requested, actually the demanded started with them, requested to the Amazonas state government to receive antivenoms, to provide antivenoms in their territories, okay? Then the surveillance foundation of the state of the Amazonas that is responsible for the snakebite surveillance and antivenom distribution in the state reported the situation to the Brazilian Ministry of Health and explained this demand from the indigenous populations. Then it was constituted a technical group, to work in this process and to design a model of decentralization of the antivenom, including people from the state, people from the Indigenous Health Secretariat, the Amazonas Tropical Medicine Foundation, where I work, that is the tertiary hospital responsible for the antivenom treatment in the state, and the 7 indigenous districts, and the Butantan Institute, the main producer in Brazil, and the Duke universities with specialists there work in implementation science. The first technical group meeting was in Manaus in 2020, okay, in the month of February. This, I don't know if you remember, but this week the first case of COVID was reported in Brazil and delayed a lot the implementation because the indigenous territories were totally closed for the entry of people that do not belong to the staff, medical staff working there. Next, the first phase of the study was to establish, after the establishment of the technical group, please don't, if I exceed my time, please, 2 minutes. Oh. Okay, after the organization of the technical group meeting, we needed to select the unities to receive the antivenoms. The prerequisites will the coverage of the unity, the presence of electricity because they need the refrigerators to keep the antivenoms stored, ability to transport patients in case of severity, presence of physicians. Then we developed a validated an application of a checklist with 80 essential items, and based on these essential items we listed in specialists, consulting specialists, we selected 14 community health centers to start the project. Okay, then we also validated, next one, we also validated a care package for snakebite treatment specialists, toxinologists, and public health specialists. Jacqueline mentioned it to you yesterday in her presentation. Then we used this culturally validated guide to train people working in the indigenous areas. Next. Here, our trainings were, first training was made in 2020, but with this delay because of the pandemics, we needed to retrain all the staff working in indigenous areas. Next. Here is the antivenom arriving in the first indigenous district, then Belém dos Solimões in Tabatinga municipality in the border with Colombia was the first indigenous district in Brazil to provide antivenoms as a result of our project. Next. Here the form I mentioned it to you to report is standardized across the Brazilian territory, and the pharmacovigilance report of the yearly adverse events related to the antivenom treatment. We collected quantitative and qualitative outcomes to show if the cost effectiveness, to calculate the cost effectiveness of the intervention. Next. The intercourses here, the problems with first the pandemics, delaying 2 years our plan, then the Yanomami humanitarian crisis. I don't know if you saw in the TV, we had very many problems with this indigenous population. Then all the effort from the Brazilian Ministry of Health was devoted to this population, delaying other health programs, including ours, with malaria and malnutrition, severe respiratory syndromes, violence, mercury poisoning. Then the extreme drought we saw in the last year, preventing, you see here, this is was used to be a river, allowing the transportation of medicines, including antivenoms, by boats to the communities. And this is also a problem of climate extremes and the problems related to access to the health care. The other, next, only to, the picture is beautiful, but you can imagine the problem for this population to go to the city, for example, for this community inhabitants in case of an accident and a snake bite, for example. Next, I am finishing. Here, this girl was the first Brazilian indigenous patient treated with inside their an indigenous territory. Was a girl, 8 year, I think an 8-year girl treated, a 10-year-old girl actually in serious condition, rescued by the health team at her home. Her father did not allow the girl to go to the health post, but then the team of the nurses went to the house and administered the antivenom in the community, in the house of the family. Then they convinced the parents and transported the kid to the health post to follow better this patient. Next, this is a project that we are starting the beginning of the next year. Here we are proposing the Ajuri program. Ajuri in indigenous language means working together in Tupi, the indigenous language. And we will conduct a cluster randomized trial. Here we are expanding the decentralization of the antivenom. And the last one, next, we'll do also a phase 2 randomized placebo-controlled trial of toxin inhibitors in community health centers in the Amazon region as a pre-hospital treatment before they arrive to the hospital to receive antivenom. Next, I thank my group, my sponsors, my funders. Next, I know you have a lot of Nobel Prizes in your country. Then I admire this from you. Thank you so much for your attention.
Thank you. We will have a global discussion at the end of the lectures.
Sorry.
My pleasure to introduce another friend, Papagaï from Martinique. We are moving from Brazil to Martinique, but we will go on traveling.
And before Martinique, West Africa, and all many people here from Africaness. Dr. Dabor? Okay. My presentation talk about pre-hospital management of snake envenoming in Martinique. Before the presentation, I want to tell you the history of pre-hospital emergency medical service in France, named SAMU. They start almost 40 years ago, based on the simple and obvious idea that it's better when the physician must handle serious emergency as soon as possible. And this system has gradually been established constantly evolving, which has become a national and international system of care. A little history of the SAMU. The flying ambulance and the works of Larrey in 1794, and you see this, the artillery box for surgeon, specialist care provide as close as possible near to the victim. And this is the first experience by Napoleon armies. We the first to treat wounded on the ground. In 19, the ambulance, the service of ambulance, we created in Paris. And the driver ambulance are guard or medical residents, and later the guard was gradually disappeared to benefit of firefight. And 1950, the medical evacuation during the Indochine War has been started. And mobile intensive or emergency care for pre-hospital, mobile emergency and intensive care pre-hospital unit in Paris. And this guide, Maurice Carra, who is the first to say that is very important to go to need to get the patient and to bring him to the hospital when you have a pandemic of poliomyelitis and many people with respiratory distress, respiratory failure. And this system is used to make inter-hospital transport of the patients. After the system evaluated, and you have the first mobile intensive care unit transport in Montpellier, in Toulouse, with the use of helicopter, and the SAMU was created in 1968 by Professor Larang in Toulouse, at Toulouse. And the first SAMU and the first number of SAMU, the 15, was created at Toulouse at 1908. Because there are many discussion, political discussion, and the law regarding SAMU was only created, only established in 1968 by Professor Larang. The mission of the SAMU, very important, is coordinating emergency medical aid quickly and efficiently. You have the call regulation, the call reception, call regulation, triage, and emergency recognition, pre-hospital emergency care, organization of transport of the patient, and organization, mainly organization of the hospital admission. The SAMU system in France was a public emergency medical system, national emergency medical system, one number for emergency medical call, always the 15. And you have one dispatching center, one SAMU per department, and Martinique is SAMU 972. And several mobile intensive care units, about 105 SAMU in France, and you have 900 mobile intensive care units. So this is the SAMU of Martinique, the Center of Reception and Regulation Center in Martinique. We have about 900 calls per year. And the system have been involved because now you have the access to care service. This is the association with the SAMU, the medical emergency, and all the care of patients, mainly non-urgent care, psychiatric care, social problems, geriatrics, and all this system is based in SAMU of Martinique and the SAMU in France. The call recept in SAMU, you have the medical regulation in the center, the public, physician, nurse, ambulance driver, rescue of firefighter, police, and all the system is coordinated by the medical regulation of SAMU. Next slide. The response to the call, you have medical regulation, we can bring advice, send general practitioner, rescue of firefighter, ambulance, and mobile intensive care unit. After the dispatching physician, after examining and analyzing the collected data by the interrogatoire, the dispatching regulation give medical answer and medical decision. 3 minutes. In 3 minutes, we go to the subject, medical intensive care unit for snakebite. You have medical regulation of bite or sting because it is very difficult to submit to know. And the medical physician have discharged the gender, the time of birth, day or night, interior or exterior of the house, forest or not, and the location of the bite of the sting. Diapositive suivante. The question is, what is the animal involved? Do you see these animals? That's the first question. This is snake, or in Martinique you have many bite or sting by scolopend, insect, plant, rodent, and diapositive suivante. And the mobile intensive care intervention for snakebite, that's for patients with severe condition. SAMU can send helicopter for remote distance and hard to reach place, administer antivenomous at the scene if too long time before arrival at hospital. Diapositive suivante. this is our data in our data in SAMU of Martinique. The file, the codification by the medical regulation assistant, but you have this number, about 103, but the physician create 65 files for patients, and we send 35 firefighters at the scene, and only two helicopters for the long distance or to the difficult to reach the patient, for example, at the mountain at the north of Martinique. Diapositive suivante. This is our data recently, because a number of case, veritable case, we arrived to the emergency department. You have 41, and you see in this 41 only 12 patients have called to SAMU, because number of patients came in the hospital itself. Diapositive suivante, and that's 1 minute for the end. You know the location of snakebite in Martinique. Everywhere in Martinique you have the patients who have snakebite, and you see in the North Caribbean you have 3, North Atlantic you have 13, and it is very, very interesting. In Fort-de-France, you have 6 snake bite in the big town. Diapositive suivante. I am finished. Overall management, the SAMUS is the system who permit overall management of emergency care, to give first aid, to give advice, to say what to do or what not to do, coordinate emergency admission to care facility, develop continuity between pre-hospital and hospital care, allow for appropriate use of resources, sophisticate, facilitate, and structure for critical patients, and less expensive care for others. Thank you very much.
Thank you very much. It's my pleasure to introduce Anna Williams. You are living here. You've got the pleasure to see this beautiful island every day.
Yes, I do.
Thank you very much for being with us and for sharing your experience.
Good morning, everyone. My name is Anya Williams, and I am a house officer at the Owen King Hospital under the Department of Internal Medicine. So today I will be sharing with you the use of antivenom and its complications here in St. Lucia. Next slide. Next. Go ahead. So this is our agenda for today. Next. So why is it so important to understand what is antivenom? So like Dr. Dabo mentioned yesterday, snakebite is a neglected tropical disease, and the use of antivenom has been very prevalent and very important in the treatment of our patients in the Caribbean, where we do have venomous snakes. Next slide. So snake bites in St. Lucia. So St. Lucia is a small island country in the Caribbean, about 24 miles south of Martinique and 21 miles northeast of St. Vincent. And because of this, we're able to share a very similar flora and fauna. And this is why we've been able to have this collaboration between the islands when speaking about snake bites. So St. Lucia's population is 184,900, and we have two major hospitals, the Owen King Hospital in the north and St. Jude's Hospital in the south. These are our main hospitals, but we do have smaller ones like the Dennery Hospital and the Soufrière Hospital, which are also in the south as well. We have 4 main species of snakes found on island. To the very top, you would see the St. Lucia racer. Then we have the St. Lucia lancehead, our St. Lucia fedulus on this end, and our famous St. Lucia boa, where you know when you're going down to Soufrière, you get to stop and take a picture with the snake around your neck. So mostly found in the rural communities with rainforests, such as Dennery, Ancillary, Canaries, Millet, Micoud. These are the areas which are more prone to snakes. The data that I found on our SELMA database that we share between both hospitals, it stated that between 2023 up to date, we only have 7 documented incidents of snake bites between the two hospitals. But when Dr. Benjamin speaks a little later on, we will see how we have an under documentation of these snake bites in hospital. Next slide. So what is antivenom? Antivenoms are purified antibodies against venoms or venom components. Antivenoms are produced from antibodies made by animals to injected venoms. So antivenoms is the only definition or the only definitive treatment for active snake bites or venomous snake bites. So the WHO estimates that 1.8 to 2.7 million people are bitten by snakes each year, and 81,000 to 138,000 die as a result. The decision to use antivenom should be based on the patient's history, examination, and pathological findings, and the type of antivenom used will depend on the geographical, clinical, and pathological factors. Next slide. So we have 2 types of snake antivenom. We have the monovalent, which is for single species or a few closely related species of snakes, whereas there is the polyvalent antivenom. In comparison, it is used for multiple species or groups of snakes, usually from a specific geographic region, which we use here in St. Lucia. Next. So in St. Lucia, this is the polyvalent antivenom that we're currently using, which is manufactured by Costa Rica. It comes by vials of 10 millimeters, and it is used whether intravenously or intramuscular, and it must be stored between 2 to 8 degrees. So this is what it looks like, and it does cover the antibothropic, which we both mentioned earlier, that St. Lucia and Martinique, we share that close relation between our fedulus and the venomous snake. Next slide. So what are the benefits of antivenom use? They are life-saving treatments. They reduce the symptoms that the patients are able to present after the snake bite. There is prevention of long-term complications, rapid recovery, and improved clinical outcomes after a snake bite. Next slide. So the complications, the known complications of antivenom, we have allergic reactions, which are generalized allergic reactions. We also have local reactions when the antivenom is administered. We have thromboembolic events, which another professor mentioned in her previous presentation. We have the possibility of serum sickness, which usually occurs after 5 to 14 days after the patient has received antivenom treatment. We have inadequate response to the antivenom. And finally, the misdiagnosis of envenomation, leading to unnecessary treatment with antivenom. Next. So the factors which influence complications that patients may present when treated with antivenom include the patient's demographics. So a lot of times the patient's age, their health condition also plays a very strong role in how well they will react to the antivenom. The differences in their individual responses to the antivenom, and also the storage and handling of the antivenom is important in its efficacy when it is used. Next slide. So this is the current regimen that we use at OKEU. So I got this from the ER as to the administration of antivenom and how many vials according to the number of symptoms, if it's light, moderate, or grave. And thereafter, it would determine if the patient is either kept in the ER, transferred to the ward, or if in a grave instance would have to be admitted into the ICU. Next. Managing complications. Pre-treatment assessment and identifying the risk factors that I mentioned earlier also plays a very high impact in our management of complications. Monitoring the patients after administration for adverse effects and alternatives if antivenom is contraindicated in a patient. Next. Recommendations for healthcare providers. So I have 3 recommendations, and the first one is the training for clinicians on the appropriate use of antivenom, and this is why we're here today. Okay, so enhancing access to antivenom in our remote areas, for example, it's not just the fact that when the patient comes to hospital that antivenom should be administered. As we heard in Papa's presentation previously, that patients don't, either the helicopter goes to the patient, they get the antivenom. So it's not just that in St. Lucia at OKU or at St. Jude's for the patient to get the antivenom. We want to see it being used more in the community health centers, etc. Public education on recognizing snake bites and seeking timely treatment. So here in St. Lucia, we do have a St. Lucia Fedelers project, which was started in 2016 to help educate our farmers, our utility workers who work in those forestry areas which have a high incidence of snake bites. Next slide. So in conclusion, despite the potential complications, the benefits of antivenom, especially in life-threatening situations, generally outweighs the risk when managed properly. Healthcare providers should be knowledgeable about the appropriate use and monitoring of patients receiving antivenom to mitigate risk and ensure the best outcomes. Thank you.
Very much, Doc, for this excellent presentation. Maybe we have a lot of questions for you after all. One of the questions will be, you classify what's the indication to do admission in ICU, is them great and others, and we'll talk about the program you are getting here. So I think we're going to stay in St. Lucia.
I feel so proud to see Anya present so very good today. And it's just what Dr. Didier stood for. You know, Dr. Didier he had vision, and he stood for successive planning, you know, and succession planning. And that's what he did with me. You know, I remember him saying, come, we're going to Martinique. You're going to meet Dabo, you're going to meet Papagia, you're going to meet everybody, let's go. So I just had to pack up and tell my wife I'm going. You know, she's like, where are you going? I'm like, going to Dr. Didier. And you know, that sort of thing. And then and it's like, you're going to do the Snakebite Symposium. And the next day I saw Keith come to my office with a whole pile of notes and papers. They said, Dr. Didier said to drop this, snake bites. I'm like, what am I doing with this? And, you know, and the process started, and we did the symposium in Martinique. And, you know, unfortunately, that was his last medical conference he attended to before he passed. You know, and Dr. Didier, you know, introduced me to Dabo and said, you know, this is your brother, and he has to be your brother, and you'll have to continue this partnership. And that's why I hold Dabo dearly, and, you know, anything he wants, he calls me, it's done, and vice versa. I have never, ever called Dabo for a patient or for help, and he's refused. He's helped me from France, he's helped me from Africa, he's helped me from Miami. I've never called Dabo. So please, guys, a round of applause for Dabo, please. He's helped us out a lot, you know. So, and I'm really appreciative of that. And also a round of applause for Anya, because she's up and coming, guys. Anya is the future. There's some bright young physicians coming up, and they're way ahead of me. And I see some of them in the crowd, and pound for pound, I think they're way ahead of me. You know, and Dr. Didier chose me, and then I'm looking at them and choosing them, and they are the future, you know, for St. Lucia, and I love to see this. So anyway, I took up some time already. It's because I'm going to do incidents and management. So can we go on? So I have no disclosures. Yeah? You know where St. Lucia is, you know where Martinique is, we're brothers and sisters. Next slide. Good, so Anya spoke about this. I'm just going to talk about our snakes a little bit. So the boa orifice, that's our boa, and this other one, the ornatus, next. These are endemic snakes to St. Lucia. So, and our St. Lucia pit viper, that's the Bothrops caribeus, which is a cousin of the Martinican snake. And I'm going to share something with you all that we discovered as well. Next. So these are the main locations of the Ferdinand snake in St. Lucia. And I'm going to talk about this because its habitat is expanding. And it's so interesting. So this was the original habitats. Over there, you see that ancillary millet basin there. And here would be that Miku area, not Miku, Denry to Miku area to Prale area here. But what we noticed is that the habitat is changing for the Ferdinand. And in doing this presentation and speaking to farmers, they're seeing the snakes going more south and more north. So we're seeing the snakes coming a little higher, like all to the Badlil, coming into the central area, and a little more stretched down here. And more on the east coast, that's what we're noticing now. So when I chatted with farmers, and I'm like, why is this happening? Some farmers postulated this theory to me that I have to investigate, which is so interesting. St. Lucia had about 3,000 banana farmers. 3,000 banana farmers with plantations back in the day. Now, because bananas are dying out as a trade crop, St. Lucia has about 300 banana farmers. So it's significantly dropped. So what happened is this: there are lots of abandoned farms. Farmers went bankrupt, farmers got older, young people are not going into farming, so farmers have abandoned their properties and so on. So guess what? There's no use of chemicals anymore. So the farmers told me, and this is very interesting, and this is what the farmers spoke with me when they told me. They said because they are not spraying anymore and not using all these chemicals that used to push the snakes away, now the snakes are re-inhabiting those territories. And I find that so amazing. And it's something I want to share with the Ministry of Health and Forestry, something they could look into. And is it that the absence of the chemicals are inviting the snakes back and they're breeding more? I actually spoke with a farmer on the Badlil, around the Badlil area. That's a little north of here, coming closer to Castries. Castries is over there. And he told me he had an abandoned property and he had some garbage and debris on it. And there was an old deep freeze, an old refrigerator. And he found 5 fertilizers inside of it. I don't know if they were breeding or anything, so he just threw gas on it and caught it on fire because he got scared. And he told me that. And that's amazing that they're actually breeding and coming up north, and that's testimony to that. So it's something that we have to look into, the expansion of the Foothills territory, which will eventually expand snake bites, or the incidence of snake bites in St. Lucia. Next. So good. So this is the fantastic thing. So genetic research shows that our Bothrops caribeus came from the American continent to St. Lucia. So it's endemic to us. But the research from Martinique shows that Bothrops lanceolatus, that's the Martinican snake, came from us. So that's the Martinican snake actually came from us. Like a lot of things Martinique has comes from us, right, Dabo? The good things. The good things. Only the good things, right? So that snake is actually a relative of the Caribbean. It evolved from our snake. Okay, so that is why that antivenom will work. That antivenom that Dr. Gutierrez, Professor Gutierrez, and the guys in Costa Rica designed, it will work for us, lanceolatus and carabies. So these two bottle species are now genetically different because they've evolved. The flora is a little different in Martinique, and they might be eating croissant and fromage and that sort of thing, and I was eating something else. Next slide. So good. So the habitat encompasses the famine belts on the east and the west coast, like I said. 90% of our snake bite patient population are farmers, usually in their gardens, a fair distance from the nearest primary health care. That's what we notice. That's the epidemiology of who the snake bite victims are, snake bite patients are. Many of the patients are aware of the presence of the fidilas, but are unprotected and unprepared. So, all these fancy things are coming out now with all those steel plates in the legs, because most of our bites are in the legs or on the hands, that sort of thing. Well, I've had a lot of bites with people trimming their bananas. So they take the dry leaf and trim, and then the snake bites them on the arm and that sort of thing. So the majority of the cases are either accidentally holding onto or stepping on the snake, and they got bitten. Next. So the Ministry of Health is supposed to be compiling some data now. We're going to assist them with that, with what we've collected individually, because I've gone around, Anya did a lot of work with collecting information at OKU, which is the central point. But I actually spoke with the people in the health centers, in the Dennery Basin, in the Ancillary Health Center, to get that data coming in, to get it more comprehensive. So some of the data I'll present now. Next, please. So good. So that's the number from 2011 to 2023 per year of fidulous bites in St. Lucia. So that's a total of 12 years. And if you look at it, males are in blue, females are in red. So the amount of the incidence is actually going down overall. And 2021 is almost identical to 2023. Right? So before we did have a lot more snake bites, and that could be because of a dwindling snake population, but now they are getting up there again. The next one. So that's envenomations by territory. So these are the territories that really where the fidulus live. So if you see Dennery here, Ancillary, Millet, I would think they would have been higher, but that's another famine belt on the west coast, but unknown. Sometimes we don't even know where those people come from, and they have those snake bites. Some are from like Babono and Maki and that area. So that's that. And yeah, next, go ahead. Right. Now, I found this slide very interesting. That's the estimated snake bite incidence in St. Lucia for the last 2 years, 2022 and 2023. So this is very, very, it's very learned for me for that one. If you notice, the wet season is June to November. So June to November, and look at the incidence of snake bites. And it is well known that, I think someone from Brazil mentioned that there are more snake bites during the floods, or during flood time. So that's our rainy season. And that's when we get flooding, we get water coming down into those villages from the forest, and that sort of thing, and they bring the snakes down. So you see that peak incidence, and 2023 did surpass 2022. And in the month of September, October, this is our highest peaks of snake bites recorded at our health facilities. So it's quite interesting, right spot in the middle of the rainy season. And so it's something we could teach our farmers and the forestry people that we've noticed from the data. Yeah? And overall, still climbing number of bites, yeah? Estimated bites per month. Next. Good. So like I said, farming and underprivileged communities. It shows the majority of the envenomations of poor farming communities. They occur on both coasts, and we need more snakebite education, like Anya said, and access to medical resources. In Martinique, Martinique has lots of money. They could fly antivenom on a helicopter, jet fuel all the way to wherever, and then fly them back to La Mena. We cannot do that. So, but we have the advantage of being smaller, so we could get our people to our facility quicker, within 2 hours or 3 hours. Next. So just some clinical manifestations. I think Anya touched on management a little bit, so I'll just run through this, and we've been through this already. So it causes local and systemic effects similar to there's something called the bothropic syndrome that the bothropes can create that we spoke about already. So the envenomation is characterized by intense local reactions, including extensive swelling, erythema, redness, bleeding at the site. We've seen lots of bleeding at the sites before, ecchymosis, and pain. About half of the envenom patients also develop systemic manifestations like hypo or hypertension, weakness, headache, allergic reactions, and shortness of breath. So these are what we've seen and we've documented clinically from those snake bites. Next. So far, year to date, we have about 6 envenomations. Now, that is separate from what Dr. Williams presented, because she said there were 7 recorded at OKAU. But when I spoke with the health centers or the polyclinics, there were 6, not including what she reported. So we do have underreporting. So we're looking at a dozen or a little over a dozen. So where are these people going? Some of them don't even get to us or get to the facility. So we do have at least 50% underreporting of snake bites envenomations or snake envenomations. So our annual rate is about 10 to 12 bites per year. We've been consistent with that. Our monthly rate of envenomations is, when I calculated it, it's 0.83 to 1 bite per month. So we at least get 1 bite every month, especially during the rainy season, which is important statistics for us. Next. So the treatment cost, so these complications are mostly diagnosed early, and the appropriate treatment instituted, whether extended antibiotic therapy or surgical intervention, because we do get some compartment syndromes. So far, hospital stays do not cross a 40-day period, but we still collected data. We need to work on our data collection, and so we can have more robust data and more robust presentations like these. Severe cases are followed up as outpatient clinics in their respective communities once we discharge them from hospital. Next. So current in-hospital management, Dr. Williams touched on that, so I'm just going to run through this. So we give analgesics, anti-inflammatories, because you get redness, tenderness, swelling. At the envenomation site, we give antihistamine like Piriton, IV to decrease the risk and occurrence of allergic reactions, even to the antivenom. We give steroids sometimes, hydrocortisone, to decrease the inflammatory response, including the pain, swelling, and the redness. We give a tetanus vaccine because a lot of our people are under-vaccinated, especially our poor communities and so on. We have lots of under-vaccinated people in St. Lucia, so we make sure we give them, because a lot of them are farmers and they're in the soil and they're working. So we make sure it's a dirty bites. We give them TED-Tox vaccines. And we use antibiotics. Our antibiotics of choice, we use Flagyl or metronidazole as an anti-anaerobic choice. And we either use augmentin or cephalosporin, so looking out for penicillin allergies as our gram-negative and gram-positive coverage. So that's what we use. Very basic, and it works for us. It works fine for us, and there's no need to change it because we don't have antibiotic resistance in St. Lucia like maybe Martinique may have. Because they have a lot more use of antibiotics than us. And we practice very good antibiotic stewardship in St. Lucia, culture-directed antibiotics, that sort of thing. So that works for us. We're keeping it that way. Simple is better. Next, please. So the antivenom, Anya touched on that, so I'm not going to go through this. We procured it from PAHO before. I'm not sure if Dabo and them are working on something for us to get it directly from Costa Rica to make it more available. Our shelf life is about, go back, please. Shelf life, oh, you really want me to finish? That's okay. Shelf life is up to 3 years if it's stored at 2 to 8 degrees Celsius. And since it's used from 2011, 2012, it has demonstrated very good efficacy for us. Yeah? Next. So most patients with envenomations arrive at the main OKEUH hospital where the antivenom is centralized within a 3-hour window. We try to decentralize it. So the basins like the ancillary polyclinic, Denring Hospital can have it. So the guys like these guys out there, Bacchus and Edgar, who work in those clinics, they could have access to it. It is our policy to, what is this? All envenomations receive the polyvalent and pre-treatment stabilization. And since 2017, no recorded deaths and in-hospital complications are depicted below. Next. So that's just some complications I put together, seen in hospital. So the majority, what we see is a cellulitis, depicted at the blue. Then we get some abscess formation, some swelling, and a very small amount of compartment syndromes, but we do see them. which we call the surgeons to take care of that for us. Yeah? Yeah, next please. Yeah, that's it. Merci beaucoup.
Thank you very much, my friend, Benjamin. We were waiting for that kind of this presentation for long. When I say we, because Chima, every time we spoke about solutions, telling me, d'abord, you need to know how Envenom is working and solutions. I told him we are working together, and we almost have the paper now. So you can see that we're talking about the incidents, it's underreported like in other countries. Maybe in the paper we will try to get much more information. And after all, I would say some good words about you. So our next presentation, my friend.
And it's all in English, I'm sorry. You're welcome, Jonathan Florentin. We are going back to Martinique, to the end of this session, with a very specific population, not population of snake, population of patients.
Thank you very much. First of all, I would like to thank my mentor, Professor Daborezier, for the organization of this Congress, and all our friends and brothers and sisters from St. Lucia to being there, allowing this great manifestation. So we will talk about snakebite in elderly patients. It is a very, very, very difficult question, and when we look at in the literature, we see some very solid article from Taiwan and from Brazil, where we can see that the age can be considered as a risk factor for severity in snakebite. It can be, in the case of Botrops envenomation in Amazonia, explained in part by the greater prevalence of cardiovascular disease. Next. But in the cases of Botrops, both in Amazonia and in Martinique, we have reported cases of cerebral thrombosis, most frequent in the elderly patient. Next. Yes, the Martinique population will be in 4 years the most elderly population of France. We are near to be the number one in the diabetes prevalence and hypertension prevalence. So you can see that our population may present a major risk of severity against the snakebite envenomation. Next, please. Botrops lanceolatus is our endemic snake. It is responsible for 30 to 40 envenomation per year. And without treatment, we observe around 30% of thrombosis complication, 14% of strokes, coagulopathy, and around 30% of deaths and 20% of definitive sequelae without treatment. The treatment is based on early administration of Botrofav, and it's allowed us to tell that it's been 20 years we didn't see any death or severe disability. Next, please. So you can see the epidemiologics of the snakebite envenoming in Martinique, where we see there is an increase since 2022 in the snakebite envenoming that we cannot explain for now. Next, please. When we compare the two populations, under 60 years old and above 60 years old, we can see that the thrombotic complication seems to be more important in the older groups, especially the cerebral and cardiac and lungs thrombotic complications, which are present in the above 60 years old group. The other complication and organ failure are similar into the two groups. Next. So, to answer this very difficult question of the management of elderly patients bitten by a snake, We try to explain this with this clinical case who presents all the difficulties of this evaluation. So what about a man of 84 years old who was bitten by a juvenile snake while making some agriculture. He had to work 3 hours to reach the fire station. When he arrived in the fire station, he presented lipotemic fainting and arrived at hospital 6 hours after being bitten. He received Botro 5 in less than 1 hour after his arrival at the hospital. Next, please. When we see the patient, we was very confident because the pain was very low, the edema was very little, and very around the bite. He had no general neurological signs, no chest pain. The arterial tension was normal and heart rate also. Electrocardiogram was normal also. But, next. When in the evolution we see improvement, we see a discrete dyspnea and chest discomfort appears. And he had a sensation of heaviness in the head. Next, please. And the first biological assessment allowed us to discover an elevation of the troponin I and the thrombopenia and also a decrease of the PT that puts this patient in a more high severity grade, because in the grade 2, the clinical grade was normally not associated with biological abnormalities. So when we made a second dose of troponin, we see this increasing is continuous. So we classify it as a severe envenomation by this information of thoracic chest discomfort and elevation of troponin. And we treated with 3 vials of Botro 5. After all, we observe a very important increase of the troponin and a secondarily normalization between 2 or 3 days. Next. When we perform some MRI or CT scan, we discover the patient have presented multiple cerebral infarction and also thrombosis in lungs, in aorta, and an acute myocarditis discovered on the MRI. The coronarographic was normal, the echocardiography was normal, and the electrocardiogram didn't change during the process. Next. The evolution was very good. The patient recovered all his similar activity, level of activity, and he had no long-term sequela or disability. Next, please. In conclusion, this case put the real difficulties to put the age as a risk factor, because we can see that when you take time to administer the antivenom, or when the severity of the bite is high, the age can be also a risk factor associated with. And we need to make further studies to improve this hypothesis of the age as a risk factor in Botrops lanceolatus and envenoming. But we can say that in botrophic envenomation, age may be a risk factor for thrombotic events. Thank you for your attention. I would like to make some acknowledgement for my mentor, Professor Daborezier, and for Honorable Dr. Didier Martin, who was also a mentor and a friend. Thank you.
Now, to conclude, I don't have to present d'abord. You know, it's only 50 minutes. I know this guy very well.
I used to be on call with him in Paris, in ICU. But every time I know he's going to be on call, I was happy because I know he's going to teach me something. He was going to teach me something. So Professor Lapostole is a good guy. It's difficult to talk after those young doctors, especially my Jonathan. I said my Jonathan, sorry for that. My colleague. So, and your Williams, Dr. Williams, I think maybe in the future you are going to take me over and him also. So that will be great. You have to talk to the team of Costa Rica and Brazil, maybe. So that is a piece I give to you. I'm going to conclude because everybody wants to get coffee. So we will talk about antivenom availability in the Caribbean and the French Guiana, also in St. Lucia. But as you can see, I'm not going to stay long because you have said everything here. You said everything. So I'm just going to do the same thing that Jonathan, because his presentation was good. I'm going to try to beat my student. So here is the case of a 42-year-old teacher. We went to the river, one of the rivers in the north of Martinique, to take her usual bath because she said she liked to go to the river every day. But maybe this day, she faced something she never believed. She was beaten by these fer de lance in the north side of Martinique. Rapidly, she didn't have a phone. I think she worked for at least 30 to 45 minutes in order to get a phone and to call Samu, Papagay. But Papagay didn't answer. No, that is a... Samu is the pre-hospital emergency. We call them, they come to you, as in his presentation, Professor Gay. He received early Botrophav when she arrived at the emergency department, but quickly she will develop shock and multiple organ failure. She has been hospitalized in ICU. My question for you. So, and she spent more than 4 months. You can see from ICU to the Department of Orthopedics, and she was in sick leave for more than 1 year, but she survived. But you can see, when we talk about disability, sequela, 1 year, and she's a teacher. What we can do with those students? Get another teacher? It's difficult. So this is a crazy case, 22 years old, another case, with a history of epilepsy. He has depressive disorders. He was admitted to the ICU following a serious envenomation because he was playing with the snake in the south of France. He said he used to see the snake, but this day he decided to play with the snake. He was beaten 4 times, but he continued to play with the snake. And at the time he said, "If you do that to me, I'm going to bring you home." He took the snake. He bring the snake home, and after all, he killed the snake. And he took the same knife. He cut one of his finger. In order for him he said, "I don't want the venom to go through my system, my body." Yesterday, Dr. Sackett, Jacqueline, she spoke about culture a little bit. So snakebite is not only a life-threatening problem, it's not only medical, but social, economical problems, you can get it. But he continued his history. But he said he was at home with the snake, he killed the snake, and you will see, that is the snake, but he put the snake in a sheet, white sheet, and when the emergency department arrived, when the emergency physician arrived, he was already in shock, because he has hypertension and others. And he was brought to the hospital. And you can see at the beginning, when I arrived, this is it, 4 times. And he had to go through the operating theater, where you can see he got surgical treatment because it was already under tension, compression, and others. But it was a fight, a journey, a fight between two different people, the snake and him. But the problem is a big global burden of snake bites. You can see in all the presentations since yesterday, we have a huge problems in the region, everywhere, from the Amazonia to the Caribbean. But the type of snake where we get more trouble is really the genus of Botrops. And Amazonia, as you heard this morning, 80 to 90% of snake envenoming is caused by atrox. When we look at this problem, the question is why snakebite envenoming? Since yesterday we were talking about the amount of death, more than 100,000 deaths every year. When we look at the region, we find out. So some of the region, like we're going quick because, and we know, and the South and the Latin America and the Caribbean, we also face some difficulty. We don't have proper incidence, proper epidemiology, so we need to work on that. And it was the same thing in the case of St. Lucia. Now we are glad that we can have some data. So we're going straight. We're not going to stay. We talk about bottle atrox, 80 to 90% of snakebite envenoming in the region. When we look at the venomous snake in the Caribbean, now we have a clear idea. If we go into Martinique, we have to be careful in some areas. If you come here with the Caribbeans, the cousin of Botrops, we talk about venomous snake. We can in Martinique we have various other type, non-venomous, but now we are in the venomous. If we talk about the Suriname, if you go up near to French Guiana, you will get some. The most important is the Botrops atrox. Also near to Brazil, you have a big presentation with a big team from Brazil. So Botrops atrox. And Trinidad Tobago, we don't have so much data. You need to give me some data because you have your friend over there. We need to build a network. When you go to Guyana, Professor Gutierrez yesterday spoke about it. And why not Venezuela, near to Trinidad Tobago? Maybe we have the same type of snake. When we look at this paper also, that is a really a short resume of different type of venomous snake we have in the Caribbean. Before, we used to repeat what other people said from Europe or another region. But now, you have some young people like him and her. We are trying hard to pull and to give some good study, some good clinical cases and whatever. Guyana, I'm not going to talk about French Guyana because Professor Atem Kalel this evening will give you an idea, a clear idea. So that is French Guyana. And I come back again to Martinique. You will see the Botrops atrox. Jonathan just said we got 30 to 40 cases per year. And since 2011, we had a new antivenom from Microfarm. He's here, the boss. And since then, we have a part of the case we just published. The case has been published. You didn't say that, Jonathan. You forget yesterday. So the whole case yesterday. So when we look at the panorama of snake bite in Martinique, we can say from 30 years we had so much complication, like stroke 15%, and the mortality rate was 13 to 15%. Today, we are glad the mortality rate is 0.0000. That will be the same thing maybe in St. Lucia and other parts in the world, but we have to be happy. This is what we used to see 30 years ago. When we talk about the stroke, when we look at the MRI for the student and for the young student, you can see some junctional stroke and some posterior cerebral arteries, both that is typical. And I believe my colleague, Professor Yosef, she will be happy to see such. And I believe he's good to see. But she was there, sorry for that. Professor Yosef, so I believe if you face those kind of imagine, maybe if you don't know about botrops, lanceolatus, maybe that will be difficult for you, even you are a neurologist, even you are a neurovascular, to interpret, because you don't have so much pathologies where you have bilateral and some lesion like that. You don't have so much pathology in the books. I'm right, Dr. Prof? I'm right? She said yes, okay. So when we look at the physiopathology, we're not going to stay long. We have some more minutes. The pathophysiology, Professor Gutierrez and others, we talk about that. So what we know now, we didn't know years ago the composition, the neutralization, the biochemistry of venom. But today we are happy to say that we know. In my case, I went to Costa Rica, well received, and I learned, and we know now the composition of the Caribeos and the composition of Botrops lanceolatus. 70%, 74%, we have more metalloproteinase, and then 15% we have some phospholipase A2 and A3. So that is a complex pathophysiology, as we said all the time. So this is the study from 2008, Professor Gutierrez. That is this paper that Dr. Martin Didier gave to me when I said, I'm upset. And he said, no, don't do that. Just write him, send him an email. So you can see in this paper, I just repeat that, and when we look at the biochemistry, and you can see the metalloproteinase is in predominant, 74, 75%, and both Botrops and Caribeos. This is the comparison. You can see they are really brothers and sisters. I think we're supposed to live like them, brothers and sisters, when we talk about Martinique and St. Lucia. Look at the clinical presentation of our patient. Usually the patient, we have a protocol, institutional protocol, where the patient usually came and with edema, with pain. This is two things, the swelling, what we call the edema, and we classify by grade 1 to 4, and French Guiana or in Brazil is grade 1 to 3, the Otero classification, but we have 4 grades. So the majority of our patients, 30 to 40% of our patients is grade 2. Those grade 2, grade 3, when we go to grade 3, grade 4, we talk about the severity, where the patient has some general symptom, where the patient has hypotension and others. We think about ICU in grade 4, grade 3. That is it. We're not going to talk about antibiotics. That is, I leave that for Professor Atem Kalel. But you see, the question is this morning, where we came from. Why it is possible or impossible to do good medicine wherever where you are in the Caribbean or in Africa? No, the response is no, none. From 30 years, 1993 to today, we came from a mortality rate very high, 15%, to zero mortality in 2024. And we have seen those patients in clinics. What we do, you talk about complication 15 days after is normal. When you see a snake bite patient, I think you need to see them 8 days after, 15 days after, and 1 month after. You have to follow up. So complication, we don't have none, and we have a Botrofav since since 2011. We have been treating like the 350 patients and no death. That is the Botrofav. And now this evening we have a presentation where instead of 10 milliliters, we have 5. Our colleague Ion Cameron will talk about that this evening. That is on a specific treatment. Why not? In the future, maybe we'll have only one, not a monovalent. Maybe that will be polyvalent, effective antivenom for all the snake in the region. Why not? So that is the antivenom we use. And in the case of French Guiana, I told you I'm not going to talk about French Guiana, but you see the complications, they are very severe in case and patient who doesn't get treated. Those patients usually we can lead to amputation, we can lead to necrosis. And in the case of French Guiana, we're going up. That is, we leave that for Professor Atem Kalel. We go back to Botrops caribeos. As you said, it's endemic here. And it's very good your presentation. We can see some area. Maybe tomorrow, if we have time, we're going to visit Dennery and Micoud, those areas. And the question is today is why after this conference we don't say antivenom and everywhere in St. Lucia. That is the conclusion. Maybe if it's an international conclusion, no one can say, no, it's not good. So maybe, I think if there is people from Micoud, from Dennery, you should be happy for this conference. Maybe you will get some antivenom in the fridge of the health center over there. That is the protocol we use in St. Lucia. That is a collaborative protocol with the University of Costa Rica. Professor Gutierrez, thank you, sir. And in terms of perspective, I'm going to finish now. In terms of perspective, next. Perspective, you can see the priority for us is to get good antivenom to treat our patient. I know WHO help a lot, PAHO in the region. I don't know if there is somebody from PAHO, but PAHO has to help everybody. PAHO needs to do some investigation in the Caribbean to look after groups, after people really working. Because it's not because I know you, I'm going to help you. No, that is a really global burden. If the Martinican group is working well, you need to recognize the Martinican group. For many years, I don't get so much attention from PAHO, from some organization. I would like them to give us some attention for our work. Thank you very much. And in conclusion, Botrops lanceolatus or Botrops caribeos is endemic, both in St. Lucia or in Martinique. We got good antivenom. Thank you to the University of Costa Rica, Colomio Picado. So you can see severe multifocal vascular thrombosis. We can get that if your patient is not treated. But for that, we need to have those antivenom. And our experience, Botrofav is safe and effective to treat Botrops lanceolatus and caribeos also in the past. Even the patient get bite and the patient arrive late. We treat patient 24 hours is my next question to you. So multidisciplinary approaches needed. Regional network, medical cooperation to treat severe snake bite envenoming, important. Efforts and research, this is what we're doing. Antivenom availability and accessibility. Teaching, delivering of health services. This is for that we are here. The teaching, education, thank you to the Ministry of Health, should be the future approach to reduce the burden of snake bite envenoming. Thank you very much. That is a batch of nurses in St. Lucia. We came to our ICU 2 years ago to get training, and we are glad to do the same project, and we need Europe to give us some money, and we will continue this program. Thank you very much.
Now, probably you've got many questions. Probably.
I have a question for our Brazilian colleagues. Is there a legal limitation to deploy antivenoms to primary health care level in Brazil? And if so, how do you plan to overcome this thing?
There are no legal impediment, but the guide, the protocol of the Brazilian Minister of Health recommends the treatment in the hospital under medical supervision. Since it's a recommendation, was not a rule at all, and then this decentralization program was approved at we have an approval from the State Secretariat of Health of the Amazonas. Since in the community health center we have a doctor, and all the items I presented in the checklist we validated with the specialists.
So you expect if this pilot project works good, you think it will be accepted overall in the country?
Yes, there is many demands from the other indigenous districts. The limitation today is the production of antivenom because Butantan is producing alone today. The other producers are expecting for or waiting for the authorization from the Anvisa, the Brazilian sanitary agency. They need to be remodeled to continue to produce immunobiologicals. But I think in the future, when if we have more antivenoms available, more vials, we can expand the program. This is what the Brazilian Minister of Health says.
Yes.
Hi to everyone. It's not really a question. I have to leave because I'm going to cast back to Martinique. I will like to address my warm congratulations to the Professor Rezi and his team. I just spent 2 hours upstairs with the specialists of catching snake, the fireman, the forestry services, and the farmers. And I saw so many questions asking what to do to fight against the snake bite, what to do in the 8th hour. It's very important to link the 2 rooms and bring the answer for the farmer upstairs. They are very interesting about all what you are doing. I think they have to see some picture of treatment, snake bite. So congratulations to everyone and try to make the link. I think it would be important.
Any other question? Yes, yes, so many. Ladies.
Okay. Hi, good afternoon. So this question is posed to Jonathan. What is the benefit of herbal medicine in the prevention of thrombolytic events?
The benefit of
Herbal medicine.
herbal medicine.
Yeah.
In Martinique, there is some practitioner who produce some medication by herbal therapeutics, but we don't recommend it. We only base the treatment on the early administration of Botrofav. We don't use herbal therapeutics on the snake bite for now.
Thank you.
All right. Thank you very much for the presentations. I think all of the presentations were excellent. I really am impressed with what I heard today, and they were clear cut, especially for St. Lucia, how to manage the cases, and I am happy that I had the opportunity of being here. I also want to say thank you to Dr. Velton. I think you've been doing an excellent work in Brazil, and I really am impressed with what has been done in such a population where, especially in the Amazonian region, where you have very, the people are very far out as such, and they have traditional belief system. There one question there I want to ask: how do you shared a little bit of it, but how do you overcome those traditional beliefs that the cultural belief the people have in relation to the snakes and so on and the bites? That's one. And the next thing is that I observed in your presentation that the persons that were very vulnerable to the snake bites were children, and they had the most complications and very severe. Is that what you have seen in the present, in your sphere of looking? Is it mainly those younger ones, or is the younger ones plus the older ones that are having most of these complications? Thank you.
Okay, thank you so much. You are very kind. First of all, you don't need to overcome traditional treatments if they are not harmful. We must respect this traditional knowledge. Maybe in the future we discover or find a molecule, for example, in these traditional medicines that could be actually beneficial for the patients. Then, for me, this is not a concern, except for tourniquets. The other, a tea of a plant they have in the backyards, or a topic treatment, if I say there is, for example, a fat of an animal, I don't see this as a problem actually. They can include, the Brazilian Ministry of Health in these territories recommend both treatments, and we need the professional, the doctors and the nurses, the official system. There is a recommendation for the official system to put together the shamans, the healers, the traditional healers, inside the same health facility to work together with the doctors, okay? This is the first one. You are correct. The extreme ages, the children and the elderly, as presented by the doctor, are the more vulnerable populations. The older are more have more cardiovascular complications. The children, we see many patients with local complications because of the volume of the limb. You can the small children, you can imagine a small limb, a small volume limb can be more prone to complicate. but in the elderly we see more coagulation disorders.
One more.
Thanks. An easy one. You mentioned the antivenom you use, Dr. Williams, as either IM or IV. Do you actually administer it IM?
So far, I have not seen it administered IM, but we do generally do it intravenously.
Right. Good afternoon. This afternoon. My question is in relation to treatment of the pregnant female. Is there any additional info you can give, and speak to us to the viability of the fetus?
That's a good one. Good question.
He asked it. That's what yeah.
There is no contraindication in case of Botrofar and pregnant women. I'm pretty sure it's the same. Polyval, I will leave Professor Gutierrez add something. Okay. There's no contraindication. We had some pregnant women we administrate in the past. Botrofar is normal, I think. If we look at the physiopathology and others, the placenta that go through, cause the placenta, but there is no contraindication.
Just to add a question, there will be no contraindication. However, would the dosage be the same as a result of the fetus?
It's the same. We don't increase or diminish. It's the same thing in pediatric patients. We got some 5, 6, 7 years old patients to get beatings. Some people believe we have to decrease the doses, but we don't. We give the same doses. For seconds.
No, it's the same, exactly.
He says it's the same. Yeah,
Oh, thank you. Thank you for this section. It's a very good section. I have a question to Dr. Williams or Dr. Benjamin about the adverse reaction. How often this occur and after you give the antivenom? And the second question is about the Dr. William told about in the use intravenous or intramuscles antivenom. In Brazil, use only intravenous. How you choose intravenous, or is it different for the choose the intravenous or intramuscles for apply the antivenom?
So from the protocol, from the antivenom that we have, it can be administered intravenously or intramuscularly. But the preferred via, it would be intravenously, because it can be an adverse reaction also by administering it intramuscularly to cause thrombotic elements as well. But usually it is intravenous, but in the case where probably we can't get an intravenous access or something like that for a patient, then now we would have to figure that, okay, so we're in the prime time of having to administer the polyvalent antivenom, and then we would have to go intramuscularly, sorry.
I don't know if it was a mistake from my part, but in the protocol, we talk about IV. Remember, you talk about intramuscular. Maybe it's a mistake. In the protocol,
So there is a discussion in the committee. The good way.
the route of administration is more quick, accessibility, more rapid, more rapid,
what Dr. Williams was highlighting is that it can be given. I am as well.
Yeah.
Give it IV. It's just a possibility that in case of getting e-matters patients or giving that IV access, we wouldn't waste time. We give it IV. But we give it IV. That's what's on our protocol right now. And in terms of the first question about allergies, we don't see allergies. We've never seen an allergy to it. But the disclaimer is that most of the times the junior doctors, ER physicians will pre-medicate with antihistamine and steroids before. Even given, so we may not even see the allergy because they've already been loaded on steroids or antihistamines before the administration of the antivenom. Yeah? So that's a possibility. So that could be a false negative. Sorry, yeah?
Yes, and this question has to be asked in the perspective of much more availability. It means the drug is available, but the way you can administer the drug is also available easily. It has to be discussed, at least. You agree with me?
Yes, sir.
Any question? You're not hungry.
Thank you, thank you. Just quickly, it can go to, basically I want to ask Dr. Jonathan and I guess to all the others there, in relation to your elderly patients, the one that you highlighted with the fact that within, you had given him the antivenom, but then subsequently it showed that he had some other reaction. My question here is that, would we keep such patient when you administer the antivenom? Do you keep them for at least some 48 hours or something for observation? Is that the normal, or do you discharge those patients? What do we do in that setting?
Thank you for this question. In our protocol, when a patient arrives in the hospital for snake bites, we have to have an observation of minimum 8 hours, even though it is a grade 2, which is the most frequent patient. During this observation time, we check for the tension, heart rate, and if there is a new clinical event, we make another blood sample, blood test. In the case of this patient, it was very complicated because there is some bias associated with this age. He walked after being beaten, and he had already severe symptoms before arriving to the hospital because he has a lipotemic faintness. So the evolution shows that he had a myocarditis, and in the past 20 years, we also observed three times this pathology. And for every patient, we have 6 to 8 hours of observation after giving the botrofab, and if it's a grade 2 and there is no complication during this observation, the patient can go back home. If there is some complication, we put it in a grade 3 and we give it another vials of botrofab, and it stays in the hospital 24 to 48 hours.
Very nice question, but we have a lot. You will have time and the lunch time to ask question to our specialists. Question about what is the use of antibiotics in this case? Which type of antibiotics? Have we done some studies? What kind of microorganism they have in the mouth when they bite somebody? All those questions we have to raise them. Histaminic, hydrocortisone, they are validated before antivenom. So we can say in that international conference that it's not validated. And what the patient they need management as another patient. A snake bite patient is another patient. It's like the one will come with dengue, will come with septic shock, or I don't know. We have to deal with that and treat our patient like another patient. A snake patient is not a snake, it's a patient first. So we conclude. José, you okay? So thank you very much for this session and see you in the lunchtime. Thank you. Miss.
Thank you, panelists. Thank you, everybody.
From today, you have to send me a mail every day.
For lunch now.